Lesson 5.9 is on the discriminant. The discriminant refers to a specific number, and that specific number tells us something about the x-intercepts. It tells us how many x-intercepts it has, and it tells us what kind of numbers they are. Like, is it a nice, neat fraction, or are we going to get one of those ugly decimals? Or is it going to give us an imaginary number? Like sometimes with the quadratic formula, if you were typing in your question wrong, it said non-real answers. And sometimes the quadratic that you have has only imaginary numbers. And I avoided those questions with the quadratic formula. But that still is a possibility. So the formula for the discriminant comes from the quadratic formula. It's this part. The b squared minus 4ac. So it's the section from under the square root in the quadratic formula. And it tells us how many and what kind of x-intercepts a quadratic has. What are some other words for x-intercepts? Root, zeros, and starts with an S. Solutions. Yep. So once you look at a quadratic and you type in this formula and you get your number, if your number is bigger than 0 and it's a perfect square. So I've listed over here and on the front of the board those perfect squares, 1, 4, 9, 16, 25, 36, and so on. If it's a perfect square and it's bigger than 0, it has 2 rational. The word rational means it's a nice whole number or a fraction. That's a rational number. If it's bigger than 0 and it's not a perfect square, then it has 2 irrational. These would be the ones that when you do the quadratic formula, you get a decimal. If your discriminant equals 0, so when you fill in the formula, you get 0, it has 1 rational. This would be an example like when you did the quadratic formula, when you use the plus and when you use the minus, you get the same number. So this is one where your quadratic sits on that x-axis. So the vertex is on the x-axis. If you get one that is less than 0, your discriminant is less than 0, then it has 2 imaginary. So these would be ones like when you try to type it in the quadratic formula, it says non-real answers. These are ones where you would have an I. Now, if you don't remember these symbols, this is greater. This is less than. So we're going to do 4 examples, and then there's a Google form that goes with it. So number 1, you do have to make sure it's set equal to 0 or it doesn't work correctly. So what is A? What is B? 12. And C? Negative 13. So we're going to do b squared. Make sure your b is always in parentheses. Minus 4. A is 2. C is negative 13. So type that into your calculator. What do you get? 248. If you are not sure if it's a perfect square, so for example, I only have numbers listed up to 144 on the board, and you're not guaranteed that those numbers are actually going to be on the board when you take your test. So if you want to check to see if it's a perfect square, do the square root of 248 and see if you get a whole number. So is 248 a perfect square? No. So let's look back at our chart. 248 is bigger than 0. Now, if I had gotten negative 248, it doesn't matter if it's a perfect square or not. Any number less than 0, any negative number is too imaginary. The positives are the only ones you have to check to see if it's a perfect square. So it's greater than 0, and it's not a perfect square. So it has 2 irrational solutions, or 2 irrational x-intercepts. You can just put 2 irrational.
That's the answer.
Well, if it asks for the discriminant, that's this number. And then if it asks for how, like the type of x-intercepts, it's this one. So either one, they're both kind of the answer. It's like a 2-part. Number 2, what is A? -1. What is B? 16. What is C? Good. It's B squared, so 16 squared minus 4 times -1 times -64. What do you get when you type this in? You get 0. So the discriminant is 0. So if discriminant equals 0, it has 1 rational. What do you notice about number 3? It's not set equal to 0. I've got to get this 10x on the other side. So how do I move that entire 10x? You subtract the whole 10x. Do I have, on the left side, do I have any plain x's over here? Just no. So I don't have anything to subtract it from, so I'm just going to write it separately. Make sure that you write it in the middle because that's the correct order. -4x squared minus 10x plus 84, and then it equals 0 because those cancel. If you don't put it in the middle, then you'll likely get your A, B, and C wrong. Your x squared is always first, then your x, and then your plain number. So now, what is A? B? And C? 84. So we get negative 10 squared minus 4 times negative 4 times 84. What do you get when you type this in?
1,444.
1,444. Is that what everybody else got? Okay. And if you want to check to see if that's a perfect square or not, it actually is. It's 38 squared. So it's a positive, it's greater than 0, and it's a perfect square. So it has two rational solutions, or two rational x-intercepts. Number 4, is that one set equal to 0? Yes. What is your A? What about B? B is 0. Notice you're missing the plane X. The one with the X is always your B. C is 24. Your whole number is always C. So we have 0 squared minus 4 times 3 times 24. And what do you get?
576.
That is not what you get. What? Negative 288. It does not matter if 288 is a perfect square or not, because it's negative. So how many and what kind of solutions does it have? 2 imaginary. And that's it.